Okay, today we're going to talk about the rules of convergence. Previously, we've drawn 1-point and 2-point cubes in perspective using a horizon line and vanishing points, which is called linear perspective. Today, we're going to take those same principles and apply them to drawing realistic objects on our page, our 2D page. But this time we're not going to draw the horizon line or the vanishing points on the paper. We're going to basically use the rules of convergence to draw and construct our three-dimensional theoretical 2-point cubes without having to have that horizon line or vanishing point on the paper. So what I wanted to show you here, I drew this in color pencil so that we could see the different parallel lines going off to the different vanishing points. So if you remember, when we start drawing our 2-point cube, we start with a leading edge, and then we connect the top point and bottom point of the leading edge to the vanishing point. So on this side I would draw this way, on the other side I would be going to that other angle. So what this represents here, the orange lines, are all of the parallel lines that are moving towards the right vanishing point. The blue lines are all parallel lines that are moving off and converging towards the left vanishing point. So the rule for convergence, remember, is that parallel lines, as they move away from our viewpoint towards the horizon, will converge. So these lines are going to get closer together as they move back in space away from the leading edge. And on the other side, all of these parallel lines, all these blue lines, are also converging, but towards the other vanishing point, which is often a distance on the horizon line. So here we can see how these lines taper. I'm going to line up my pencil here so you can see this angle. As I raise this angle up to the next line, you can see that it's a little flatter. As I go up to the next angle, you can see that is a little flatter as it moves away. And again, I go up to the top angle, and again, it's flatter. So all of these lines are getting a little bit closer together as they move away from us towards that horizon line. We can see that on the other side as well. So we have our bottom line, our bottom angle, and if I raise that up to this middle line, you can see it's a little flatter. I raise that up to the next line, it's a little bit flatter, and the top line is a little flatter. So again, these parallel lines, although in the real world they never meet, but in linear perspective and using the rules of convergence, we know that they taper and get closer together as they move away from our central viewpoint. Now, the thing that's most difficult about learning the rules of convergence and applying them is that we have to make this a gradual, even change. I will be checking to see if the rate of change of all of these lines that are parallel feel the same. So another thing to note is that these lines are tapering or converging at a faster rate than the blue lines. Now, why would that be? The main reason is that our box is turned at an angle, and so this is a sharper or more acute angle here, which means that this side is shorter and it's also closer to the vanishing point. So these perspective lines that are on the side closest to the vanishing point will recede or converge faster they will taper faster than the side that is further from the vanishing point. So on this side, I know it's further because it's a more open angle, it's a wider side, and I'm seeing more of the left-hand face in this view. So these lines, although they converge and taper towards the vanishing point, they do not converge as fast or as quickly as these lines do. So one way we can see that is when we go back to our 2-point perspective cubes using the horizon line and vanishing point. So here you can see that, for instance, this cube is closer to the left vanishing point. Because of that, the left side of the box is sharper, it is a more acute angle, and it's not as wide. This is all because it's closer to the vanishing point than the other side, the right side. We can see more of that plane. On this top cube, it's the opposite. So the cube is placed closer to the right vanishing point, and you can see how these perspective lines are getting really close together quickly. So this is what I mean. The rate of convergence on a side that's closest to the vanishing point will be faster, they taper quicker than the side that's further from the vanishing point. But another thing I wanted to talk about is the baseline. So you can see here on this example, I've drawn a baseline, which is basically a theoretical horizontal line that just touches the bottom edge of my leading edge of my cube. I use the baseline to help me consider the angle of my cube. So today we're going to be drawing theoretical 2-point perspective cubes. So we're going to be inventing them, but I may ask you to draw a cube below eye level that's turned slightly, showing more of the left face. So in that case, you might draw something similar to this. If it was below eye level and turned more to the left, so we see more of the right face, you would draw something like this. If I drew a leading edge with symmetrical angles like this, then I would be drawing a centered cube. So it would be perfectly equal on each side. So what we're going to do is try a new page, and we're just going to draw several together. And the more that we do it, the easier it will become. Okay, so for this you can use one of your graphite pencils. I'm going to do mine with color pencil just so, again, we can see and reinforce the process of drawing our 2-point linear cube freehand without using vanishing points, just using the rules of convergence. But a graphite pencil is great because it's easy to erase, and so that's what I would suggest. Like your HB pencil would be fine, and have your eraser handy if you need it. We're going to draw freehand straight lines, and we're going to do a series of these. Again, we're drawing linear transparent cubes. We're going to be drawing them below eye level. So as if we're looking at an object, maybe sitting on a table. We're always going to start with our leading edge. So we draw that first. So I have a vertical line, and what I'd like you to do is draw a centered cube. So to do that, we need to make our cube symmetrical. And we're going to show the top of the object, right, because it's below eye level, and because it's 2-point perspective, we're going to see two sides of this cube. I'm going to draw a subtle angle here on the top of my leading edge, and what I need to do for the bottom is this would be parallel, but we need to make it converge. So I'm going to draw an angle that's a little bit sharper. So I just imagine that, because again, we want it to converge towards that vanishing point. I have this angle and this one is flatter, or vice versa. You can start here and this one's sharper. Now I want to make a centered cube. So what I'm going to try to do is mimic this exact angle, and an easy way to do this, remember, is to draw the baseline lightly so that I can easily see these angles. And I'm going to draw the same angle. I'm going to try to. So let's see how that looks. Oh, good. So this one's a little sharper. This one's flatter because we want them to be converging as they're moving towards that vanishing point that's off the page. Okay, so one way we can check our work or move on to the next step is to bisect the angle. So I'm going to use these angles here. I'm going to find the center, very lightly sketch how wide. Remember, I'm dividing this corner, trying to find the even triangles. And where it hits my perspective line or my diagonal line, I'm going to drop a vertical edge. Now my goal is to create a centered cube. So I'm just going to check my work right now. I'm going to measure the width, and it looks like the width of my right side is a little bit bigger than my left. So I'm just going to make that a little wider because I want them to be equal. Okay, so now I have to draw the interior angles. And remember, once I have my new points, I draw the opposite vanishing point. So this line is going to be parallel to this one, right? But it also needs to converge. So I just lightly sketch what I think it should be. And again, I check my work, like there's this angle, and if I compare it, it's a little bit flatter right there, so that's good. Now also you need to draw this line. This one is the hardest to draw, and so I very lightly kind of guess where this line goes, but I draw it really long because it's easier to compare this interior bottom line with this middle line than it is to compare it to this one, for instance, or this one, which is further away. So I'm trying to get that angle towards my vanishing point, but it's slightly converging. I'm going to check my work. So there's this angle. If I pull it up, it's converging. Oh, shoot. If I pull that up, you can still see it's converging. Pull that up, still converging. So that's really good. Now I repeat for the other side. Use my orange one. So I'm going to connect this to the other vanishing point. And this way as well. Again, I'm going to extend this line. That looks a little too flat. I'm extending it pretty far because it's easier to compare to this line. It needs to be very similar to that one, but slightly converging and converging. Now, if I've done a good symmetrical cube, then the front line and the back line are going to line up exactly. And it looks like mine is just very slightly off center. So you can see where these lines are crossing. Okay, so if you have a perfectly centered 2-point cube, then the front line, the leading edge, and the back edge of your cube should line up in a straight line. This is close, not quite perfect, but see if you can get pretty close to that. The last thing I would do is to add line weight. Okay, and so now I have my 2-point cube almost perfectly centered below eye level. We're drawing it transparently, so when you do the line weight, make sure that the front lines are clearly darker. Let's go ahead and try another one. This time I want you to draw a 2-point cube below eye level, but I want you to rotate the cube to the left so that I can see more of the right hand side. So turned to the left. So the left side will be smaller and the right side will be larger, or it's actually wider and this is more narrow. Okay, so go through the steps one more time and we'll see how that turns out. For homework, you're going to have to do a 2-point cube below eye level. It needs to be off center, so that means it can be turned to the left or turned to the right. It can be rotated. It should not be centered, but off center somehow. So again, we'll see the top of the object and we'll see 2 front sides. One angle will be sharper, a more narrow side. This side is closer to the vanishing point. In this case, it's rotated more to the left and we're seeing more of the right front face. This angle is more subtle, so when you're starting to draw your cube and you want it to be off center, make sure that these angles are different. One will be closer to horizontal, and the other one will be more acute, further from horizontal. This will be more acute. This will be a little bit bigger. Okay. Remember to look through chapter 5 in the textbook. There's a lot of great resources in there, including a page with common mistakes. And so if you kind of go through that list and see if your drawing has any of those problems, like the top is too flat, or your parallel lines are not converging, or your box is too rectangular. Those are all things that you can look for to see if you've drawn an accurate 2-point cube below eye level. Now, what I want to do is walk you through drawing a doubled cube, because that's the second part of your homework. So let's go to a new sheet, and I'll show you how to do that. So just the same way that you're going to do your 2-point perspective cube, your first set of homework, we're going to start that way for our doubled cube. So here I'm just going to start kind of closer to the top of my page, but not too high, because we want to see the top of the box. So imagine that. For your 2-point homework, you're going to do a 4-inch leading edge, which is about this big. So like my 2-point cube would be over here, kind of large. So that would be the leading edge. For your doubled cube, you need to do something a little bit smaller. I would say no more than 3 inches. So let's do something like that. Now I'm going to do it off center, so I'm going to make one angle sharper than the other. This one's going to be more subtle. I'm going to construct my 2-point cube like I normally would. Going to be something like that, but you can't stop there. You have to draw it transparently, because for our doubled cube we're going to need, again, to see the inside of the object. So make sure that you draw those inside angles as well. Again, we're hoping that these will line up on our cube, and that looks pretty good for a proportion. But please double check the proportion of your 2-point cube, the top of your box, your doubled cube, before you start doing the next step. So I'm just cleaning up my lines a little bit. I'm just darkening the front because it's easier to see. The next thing is we're going to X the plane, and you've already made a construction line, but you're basically going to draw an X on the front plane of your box, like this, to find the center point of that plane. And we're going to do the other side as well. So I already have my bisecting angle here, and where it goes from corner to corner, my X, I get the center point of this plane. I'm just going to erase a little bit because it's hard to see what's going on here. Okay, so I X the plane. Then from that new center point, I drop a vertical line to the edge of my cube, and I do this on both sides. What I'm doing is finding the exact center of this angle. We can't just divide the line in half because it's in perspective. The front half of this line is a little bit wider than the second half of this line. You know, things that are closer to us are larger, things that are further back are smaller. So that's why we X the plane to find the perfect center. We do drop a vertical line and we get a new point there. Now, the next step is to extend your vertical lines down the page. And I love drawing doubled cubes. It's actually, I think, really fun. And I'm even going to extend my back line back here. Okay. Now, what I'm going to do is project a perspective line through my new center point of my object. So basically I'm going to have one cube here and one below it. Just as I X the plane here, this is going to be the new center to X my plane for my doubled cube. And this can get really wily when you extend these lines. The goal is that these intersect on the vertical line that you dropped down here. And so I do it from both sides. Okay, so wherever those lines intersect, I connect, but I'm still keeping this in mind that all of these parallel lines are going to the same vanishing point. So I can really tell if I've divided the cube correctly, if this dimension looks realistic, like similar to this, and also that this angle is converging at the same rate as these other angles. Let's try this other side. Okay, not too bad. Extend this and see. This side we see more of, it's further from the vanishing point, and so the convergence here is more subtle. Little flatter, little flatter, little flatter. The convergence on this side is more subtle because we see more of this front plane than the back plane. Now you can continue this on the back side. So, but it's a little complicated here because we have so many lines. So what you might do is erase your construction lines in your top cube. So we can see the inside planes of your box. So I'm going to X this plane. Find the center point and drop that down with a vertical line. And then now I've found the center of this new plane, which is going to be the doubled side. So again, I'm hoping when I connect this line that it lines up here. That's perfect. And when I connect this line until it hits here, this should be the back bottom corner now of my cube. Let's also X this plane just to double check our work. So this is the furthest back face. I find the center point, I drop a vertical line, and then I connect from the corner through that new center point of my doubled cube. And again, it should meet at that same point in the front. And then over here from the corner through that center point. I know there's a million lines here. What I'm hoping is that it gets close. It's a little bit lower than this point, but that could be that I didn't draw this line very straight. All right, once I figure out the back dimension, then I can connect these lines again. And again, I'm looking at, is this going to the same, does it seem like it's going to the same vanishing point? And it doesn't look too bad. Now, I know that looks crazy. What you can do is erase your construction lines, but I'm just going to darken my leading edge now of my doubled cube all the way. And I'm going to darken the front lines on the bottom. And I know this is a little bit fast and messy, but that's okay for now. When you do your homework, it would be great if you could make it, use your line weight to kind of clean up your drawing and make it a little easier to see. All right, so that is a doubled cube below eye level with a little bit messy, but with line weight. Okay, again, in your book, you will find examples in chapter 5 on how to draw the doubled cube. This is an example of another vertical doubled cube, but in this case, I drew the bottom cube first and then extended the lines upward, but it's the exact same premise. So you can see how to construct that doubled cube in 2-point perspective. All right, the last thing is to go back to Canvas, look at the assignments. There are, if you go to the home page and go to the date for today's class, you'll see the links to the 2 assignments that you have to do.